Hi, Assalamualaikum everyone. Welcome to Teacher Nina's Science Process Skills class for Science Year 4 DLP. And today we are going to learn about controlling variables. Are you ready? Let's go. So these are the 12 science process skills that you need to know. And we are at the 10th process skill now. Wow, I'm so excited. So what is actually controlling variables? Controlling variables is determining the elements of an investigation. So if you want to do an investigation, what are the elements that we have to control? So that is the meaning of controlling variables. Okay, let's say you are making a statement. Okay, guys, this toy car is the fastest. What? Really? Prove it. So how are you going to prove that this particular toy car is the fastest? It's like it's like this. When you are being a scientist, you cannot just simply blurt out a statement without the data, without the proof that whatever you are saying is true. Okay, let's say, for example, one person say, I am the fastest. Well, prove it. How are you going to prove it? How are you going to prove that you are the fastest runner? So you have to carry out an investigation. You have to race, right? So this is about the same. Okay, let's say the fastest car. This is a toy car, okay? So to determine what are the elements to investigate which car is the fastest. So first, remember last week we have learned about defining operationally. So we need to define operationally what is the fastest car. So we can say that the fastest car is operationally defined as the car that reaches from point A to point B in the shortest time. That means, for example, we have a few cars and we have set that all cars must reach within, let's say, 20 centimeters. So we'll see which car can reach that distance, that point A to point B, in the fastest time. So that is the definition of operation for the fastest car. So next, we need to see who are the competitors. So if you are saying that this purple car is the fastest, then who are its competitors? You are comparing this car to what kinds of car? So that is why we need to set the values of the parameter. We have learned about that last week, right? If you can't remember, look back at my videos and search for defining operationally. So you will be reminded back of the meaning of parameter and also defining operationally. Okay, next is fair play. When you want to do an investigation, for example, this car, you want to say that, oh, yes, my car is the fastest, no matter what. But being a scientist, you must be really objective. You must not cheat. You must be open to all the elements that can give an impact to the result of your investigation. Okay, so you must be really fair. So you must, in order to make that investigation fair, you must know which elements you have to keep constant. Okay, so that it will be fair. And last but not least, seeing the result. Okay, so we will see the result by looking at the same quantitative parameter while using the same unit. And it is better if you use the same tool. For example, if you want to know the time taken, so you use a digital stopwatch, then everyone must use digital stopwatch. Okay? All right, so let's look one by one in detail. The fastest car. So to define what is the fastest car, you need to have these quantitative values. The distance must be precise. Okay, this distance is how long is the distance? 20 centimeters for a toy car. Okay, and time taken. So what unit will you be using? Okay, you must use metric unit, for example, seconds. And then the competitors. So you need to have competitors with a fixed parameter, and you can choose only one. Okay, what do I mean by that? So you want to say that your car is the fastest compared to other cars. So that other cars, what is the difference between your car and the other cars? You must put the same parameter. For example, tire, the size of tire. Okay, mine is a bit bigger, maybe yours is a bit smaller. Let's see if bigger tires can make the car go faster. Okay, so that is one example of determining that, setting that parameter. Okay, so just choose only one. Oh wait, okay, let's fix the size of the tires, but I'll use a lighter car and yours will be an even heavier car. Let's see which car will move the fastest, or even the length. But you must remember to choose only one. You cannot have more than one parameters change for your competitors, between you and your competitors. Okay, and this relates to being fair in this investigation. So when you have set the competitors parameter, so the rest of the parameter must be constant. For example, just now, to know which car is the fastest is the car that moves in the shortest time to a set distance. And also the condition of the route, for example. Okay, the condition of the route, it must be like my car will go, will use a very smooth plane, for example. And yours too must be like that. Okay, but there are also other parameters that are not relevant. For example, the color of a car does not determine how fast it will go, or even the name. Okay, the name of a car, like for example, turbo versus snail. That is just the name of a car. So it doesn't relate, it is not relevant to the speed of the car. Okay, and the result. So the measured parameter of the operational definition is, remember back the definition of operation, sorry. So it is the time taken for the car to reach a given distance. Okay, so we will see that result. So again, I'm going to put it in the terms that we are going to use over and over again from now onwards. Okay, just now I just used the layman terms, for example, competitors, being fair, and also result. So now I am going to introduce to you the terms, the variable terms that we are going to use from now onwards. Okay, number one, we have learned about this last week. Defining operationally, remember, the fastest car is the car that reaches the finishing line in the shortest time. Okay, so this is the first variable that I want you to remember. Manipulated variable. Manipulated is what is changed. That means the competition, the competitors. So what are the parameters? Okay, the same parameter but different value. Okay, so the size of the tires. So the parameter is the same, the size of tires, but the value is different. Mine is maybe bigger. For example, 5 centimeters in diameter, and yours may be 4.5. Okay, so that is the manipulated variable, the difference between the competitors. Okay, next is constant variable. So constant means things that you need to keep it same. It must be the same throughout so that your investigation will be really fair. So in this investigation about determining which one is the fastest car, the constant variable is the distance for the cars to move Okay, the distance, we have set that, and also maybe we set, okay, the length of the car must be the same, or the weight of the car must be the same. Okay, so that we can note really what actually can make the fastest car. I want to know which car can move the fastest so that next time I will buy or I'll make a car with that values. Okay? And last but not least is the responding variable. Responding is the result. So remember, responding is the result that we want to know from this investigation. So the time taken for the cars to reach the finishing line is the responding variable. So besides making an investigation to find out about which objects is better than the others, we can also investigate the same object, but we change the conditions. Okay, for example, these two plants, they are the same type of plant and the age is the same, the size is the same. So what we are going to change is the condition that we are going to put these plants in so that we can see what will happen to them. So that is why you need to know what is the objective, what is the purpose of your investigation. Okay, so to define operationally, a healthy plant is the height of the plant after 3 weeks with different amount of water. So that is what we are going to change. We are going to change, see, the manipulated variable, the volume of water given. So we are going to water these two potted plants with different amount of water. For example, the left one, we are going to put just 1 cup of water every day, and the next is like 7 cups. So we are going to see which one will be healthier after 3 weeks. How would you know which one is healthier? By the height of the plants. See, look back at the defining operationally. Okay, next. Constant variable is the type and size of plant. It must be the same. Okay, it must be same. You cannot compare between a balsam plant and also a durian tree. Of course you can't. The size of the pot must be the same. The size of the plant must be the same. Okay, and the presence of sunlight and air. And what do we want to see? The responding variable, the result. What result do we want to see is the height of plant after 3 weeks. Okay, so we're done. For the explanation part now is task time. Okay, so again, I know this is so technical, but I am going to give you a task that is quite easy because you are just going to match. Okay, so we have 2 vases here. Okay, both of the same height, and for vase, usually we want to see the stability. So here, the stability of a vase is operationally defined as the time taken for the vase to fall after being lifted from the same side with the same amount of force. Okay, we're going to lift these 2 vases from for example, a plank, and we're going to see which one will fall down the fastest. Okay, so these are the manipulated variables and also the parameters. So you just need to match. I'll do the first one for you. Okay, so you need to do the rest. All right, next is this experiment. Okay, so there are 20 seedlings in box A and 12 seedlings in box B. So you just match. Okay, and number 3, this is an experiment. See, 2 cars of the same, maybe same type. Okay, but look what is different there. Okay, 3, 2, 1, go. Okay. So this is the experiment. So the fastest car is operationally defined as the time taken for the car to reach the end of the track. So these are the variables and the parameters that you need to match. Okay? Are you okay now? Well, I know you're awesome. Okay, that is all for this week. See you next time. Bye. Assalamualaikum.